So thank you very much for this opportunity to introduce a research in mathematics education which is perceived differently by different people. And I'd like to draw you a big image about what research in mathematics education is. And I will do it on the results or some results because we don't have yet all of them collected or analyzed the data, and they were collected within the MaTeK project. And we cooperated in the research with other 4 universities, one from Czech Republic, one from Italy, another one from Norway and Turkey. And I would like to say that MaTeK project wasn't a research project originated. It was a project for institutional networking and how to network researchers in mathematics education, then not through research in mathematics education. And what was the topic? Well, mathematics education, and it's also hidden in the acronym of the project MaTeK, like mathematics teacher knowledge. This is a framework which is focusing on specific skills and knowledge of future teachers and also already in-service teachers, I will call them, those who are in practice after the proper teacher training. But this framework is very wide, so we have to narrow it down. And we narrow it down to design capacity because mathematics teachers, one of their skills they should have is to design a lesson. It's not like I'm entering the classroom with there is 20 tasks to solve and that's it. This is not education. This is like training of procedural skills. It is important, but it is not the only thing that should be taught or should be done in classroom. So, but again, design a lesson, how, for what topic and such. So we were thinking, what is the area which permeates with all these topics or subjects or particular parts of mathematics? What is the permeating things in geometry, algebra, functions, and all? And we find that, yeah, it's reasoning and proving. I think that everyone here somehow feels that to be able to provide reasonable reason or reasonable argument or to prove a statement, it's one of the skills that we should know, especially if we are speaking about mathematics. And from this we derived our main or key research question of whole project, and it is how can pre-service mathematics teacher design capacity in terms of reasoning and proof be enhanced. And of course, to start with it, it's still quite wide. We need to know the status quo. So what do we start? In the first phase, it was so-called context and need analysis, and we started with textbooks. Textbooks are the resources which every teacher has, every pupil has in a classroom, and we were asking, what are the reasoning opportunities in those textbooks? What can teacher use, and what can pupils do with them? I'm not going into details since, as you can see, there is a post related to that. Just a spoiler alert, we developed a new framework to analyze them. So that was first thing about the resources. That they are in classrooms. Who else is in classroom? Of course, the teacher. So we wanted to know about the teacher's use of resources, particularly when we are speaking about effective teaching of reasoning and proving, or how to do that. And we did it through a survey. I will speak about it a little bit more. And of course, there are also pre-service mathematics teachers, so that teach students in their master level who are going to teach. We hope that all of them will going to teach, of course, but yeah, reality is different, but it doesn't matter that we are all preparing for this path. So my speech will be related to the points 2 and 3. So I start with preparation of future mathematics teachers. So how the intervention was conducted. I'm not going into details. I just wanted to show you that after months of thinking and online meetings since we started during the COVID era, and so our networking was mostly online, we suggested this, that intervention that way, and we collected a lot of data. It started before the session one, there was a group interview, we call it pre-interview. After all of this was so-called post-interview, again in groups, and we collected several documents. All sessions were videotaped, also enactment of the lesson based on the winning lesson plan was video recorded. There are several other documents we have to analyze, like exit cards or reflective text, all the assignments which were given to those students who participated on that intervention. And of course, they sign a consent that we can do that. We can't just enter the classroom and do the research. It would be not ethical. So this is shortly about the intervention. And the last part, after the fourth session, there were 2 months gap, but not like we were doing nothing. We were still working on it. And the last point of that intervention was learning internationally. And we see this, and we still consider this as a key result, because on this meeting, there were groups of pre-service mathematics teachers from all 5 participating institutions who met and who worked collaboratively in a mixed international group, and they find out that their program, their teacher, not that way, the other way. Oh, one more, yeah. It's too much. I wanted to show you, that picture. So here you can see that they were mixed in groups, and they find out that teacher education program really differs within the countries. There were the countries, when I was mentioning them, you can imagine their geographical distances. And their geographical distances somehow reflect in the both extremes. So those, for example, Italy, in which they have to finish the pure mathematics classes, and after that, after master in mathematics, they can go and attend the didactics of mathematics classes, and after that they can go to teach. On the other extreme was in Norway. In Norway, we can barely speak about mathematical knowledge of those teachers. It's so focused on general pedagogy. It's so focused on the soft skills in that classroom and about supporting and taking those children somehow in a not a good mood, but the mood to solve some problems, that meeting these extremes, it was like a cold and hot. It somehow have to crash, and it crashed a good way, because they realized, especially those from Italy, that 1 year, so 2 semesters of didactics of mathematics isn't sufficient for them to be able to teach quality. The quality of teaching, they saw that with discussion with Norway students, with Slovak students, Czech students, that they have so much more skills. They are better prepared somehow for teaching. And that's what we find like one of the key moments, and we said, okay, we did a good job, but what is the implication? In all 5 countries, and institutions, I can't speak about the other institutions, only those which were involved in the project. What we realized also thanks to that intervention, that the courses of mathematics education has to be changed. And we changed it to focus in line with the results and our observations, that there should be more stress on task redesign or design. To take a textbook is not enough, and I will speak about why from the survey with in-service teachers. There should be more practice-oriented approach to reasoning and proof in a classroom. So how to do that? On one way, in here and also in other institutions, but Norway, the students, to be a teacher of mathematics, they have some level, or stronger or less strong level of mathematical knowledge. So when we ask them what the reasoning and proof is, it's direct proof, indirect proof, proof by contradiction, and that's it. But you can't enter the classroom with this knowledge. It's the top. But what is before? There is something else. So how can I prove quite easily and to appropriate cognitive level of the pupil, for example, that sum of 2, even number is again even? Why it holds every time? How can I be sure about that? How can that pupil can be convinced that it works? So this is one extreme. So we start with some empirical argumentation and some models and different types and modes of reasoning, and it goes to the end. And at the very end, is the mathematics which is taught in the university. And we have to bridge this, the university mathematics, with the mathematics which is taught in our primary and secondary schools. So what more? Collaborative planning and peer feedback for lesson plans, reflective practice on enactment of that lesson plan and student response in that classroom. And what we are, particularly in this institution, we are very missing, and we still think that this is very obvious as normal, is noticing skills. How we should support or how to help our future mathematics teacher to recognize that opportunity for reasoning in a classroom, not just follow a procedure, but to be able to show that mathematics is not a cookbook. Because the way how it is sometimes learned, it's just a cookbook. Take this formula, put the numbers, here's the result. Okay, another problem, another formula, another numbers, another results. And we don't want it that way. That changing, you can object that, but the mathematics is still the same. While we are dealing with how they are doing that in Norway or Italy or somewhere else, that education of mathematics should be also the same. Well, it's not. And that's kind of byproduct of our research, because we have data which supports something which maybe some of you already feel. It is like that. There are huge cultural differences among the countries, among the regions. Also in Slovakia, among the regions are huge cultural differences. It's 2 years when we started with that intervention, and if you would compare that first year and this year, it differs significantly. And so have to, the adjustment of assessment tools, methods, form, and everything is really, really crucial, and we have to keep it in mind. So this is the part about pre-service mathematics teachers. And what about the in-service teachers? We conducted a survey, and we asked, it was a questionnaire survey followed by individual interviews. And in the pilot study, so around 100 teachers, we asked them about 35 questions, which were related to their perception of reasoning, improving activities, the curriculum, and such. And what you already can observe from the picture on the slide and some text here, we are not in the same group with Czech Republic. Who would say that? It's like, oh yeah, we once have been Czechoslovakia, it has to be very similar. But as you can see, it's not similar at all, because our teachers from pilot study, it shows up that they are in a group with Turkish teachers. And how we can characterize these teachers? Those are teachers who often include reasoning improving activities into their classrooms activities. They strongly agree that that reasoning improve should be an essential part of curriculum, but in the same time they think that state curriculum, which is obligatory and has to be fulfilled, doesn't offer sufficient reasoning and proving activities for pupils in classrooms. And what was surprising to us if we are focusing on, or if they want to do reasoning and proving activities in the classroom, they are omitting textbooks. They use books other than textbooks, so mathematical books or something totally else, but not textbooks. In the main study, when we slightly adjusted that questionnaire, and we, of course, also that was followed by individual interviews with teachers who were willing to be interviewed, we focus more on their beliefs about the importance of reasoning and proof, use of resources, and their self-confidence about teaching reasoning and proof effectively. And I'm not going into details. This will be hopefully published. We are in the second round of review process of that paper. But some implications I can share with you now, that teachers are not self-confident at all in every of 5 countries which were involved in that study. So even those who were attending the pure mathematics classes for 5 years, they are not confident to teach reasoning and proof in secondary or primary schools. Primary now, I mean the grades 6 to 9, like lower secondary. So what we should do is to prepare focused teacher professional development and bridge this gap. So they know it is important, but they are not self-confident at all. And we can do it also not only through that professional development, we can share it in journals or online professional platforms to somehow make them familiar with RMP-focused materials. And similarly to what I said about the courses, we just can't take any course and use it one-to-one without any changes. It holds also for resources. We just can't take any textbook from around the world. I mean textbook for grades 5 to 13, so whole secondary education, we are preparing teachers in here, and use it. And the reason is the same. There are big cultural differences. And those textbooks and also any resources, whether they are digital or not, should meet somehow specificity or specific country or regional needs, so the pupils are able to follow what in the textbook is. And from the research also, we find out that textbooks and self-created materials are fundamental for teachers, which make us feel that we need to support them in development and sharing high-quality materials. We're already starting to do so in another project, and you can find it in poster session later after my speech. So I'd like to invite you to that. Also, teachers are lacking materials, and therefore we decided to prepare a material which is focused on reasoning and proof. So this is an exercise book, Reasoning in Mathematics, and for those who know it, who are teaching it, or their pupils, or the children are now studying in grades 5 to 9, maybe you know Nový pomocník, and this is the very same order of the teams, and it's in line with currently used curriculum. But the activities are more focused on reasoning and proof and differently. So we are not asking after each task why and why. Yeah, that question why can be stated differently, and that's what we did here. So you can download it for free from the project webpage, or you can use this QR bar, which directs you to the webpage of our division of didactics of mathematics. So what are the challenges? It looks like everything went smooth. It was fantastic 3 years. We traveled 1.5 years because the rest of the time was just COVID situation, and we cannot leave our rooms. So these challenges are still open, and they are often discussed on mathematics education for us, like big congresses, kind of CIRMI conference or ICMAI, and it is how to bring theory into classroom practice. So how we can transform what we find out in our research, how can we transform it and make it adaptable in the classroom? The other challenge is how to address equity and diversity. In a classroom, there are not only pupils who are interested in mathematics, there are pupils with different needs, they have different backgrounds, abilities, skills, learning preference, styles and such. And last but not least, of course there's much more, but I picked these three because I somehow feel that they are important. How to measure complex learning outcomes, not how fast they can solve, let's say, quadratic equation or inequation, but how they can reason, how they do problem solving. Do they have problem solving skills? Can they do that? How to measure conceptual understanding, not only procedural. Procedures are important, but without conceptual understanding, it's just a machine who is following instructions. How we can do that? Well, I have some possible solutions, and these solutions are strongly related to the work we are doing here. So we need to target or to somehow reach the target groups we are working with. And one of it is let's start work with in-service teachers. So we are preparing annual conference for them. 2 days with directives of mathematics is always first week of September. Then cooperating on development of curricular documents and resources as textbooks or curriculum itself. Then prepare a focused professional development. Yeah, maybe you heard in television or whenever that teachers can somehow go for professional development, they have some credits and such. But the development is not about the credits only, that should be something which helps them in their career and in their classroom, everyday classroom reality. So we can focus on assessment, that's a big topic, how to assess objectively how that pupil know, understand and such. And then about reasoning, about new curriculum, about new methods and more. So this is working with in-service teachers. Then we of course should prepare our future mathematics teacher in a way they can jump in that fast-running train and they are able from day to day do all the decisions in that classroom and they understand what is happening. And they can support thinking to somehow, not thinking in general, mathematical thinking, especially logical thinking. Now the project is over, but there are still a lot of data which are not analyzed yet because it took some time to do video analysis, to do all the thematic analysis of the documents. But I shared at least part of the results we already have. And now we are starting to do, we like challenges, so we started do research just beyond the mathematics education, and with cooperation of the Division of Didactics of Physics, we started to focus also on challenge-based education and implementation into educational process. And why? Because we are still lacking students who would like to study STEM. And we can't do that if this is all the mathematics and that's it. Then, new lesson, this is the physics. Are there any links between it? Are they somehow connected? So this is what we are doing now, and if there will be another or continuation of these connections, so maybe next year we will prepare a poster about that. But what you can do now, you already saw, or you had the opportunity to saw the 2 posters of our doctoral students, but there are 4 other posters, and I would like to encourage you to stop by and learn a little bit more and a little bit more in deep, because that's what I just presented you was very big picture of what was done within the project. So thank you for your attention, and I'm looking forward to answer your questions.